Hello, good morning again. This is Hasan Aktarakçi. I'm joining from our Madrid office. I hope everybody can hear me. Um, if you like to speak, you can just raise your hand. You will see it on your webinar. There is a question mark and hand sign. If you like to speak, you can just raise your hand. I will just unmute and you can speak. Then you can also type your question with question mark, and I'll try to answer you. So we have about 10 people, 11 people at this moment. So we're still waiting more people, but let's just start. So just please go ahead and ask me anything about resistivity imaging related our instruments and software. Okay, I see that response now is coming, and I see the questions, so I'll try to answer now. Hello, Jawad. Okay, one question is about how efficient AGI instrument in groundwater exploration using electrical resistivity techniques? Well, that's a good question actually. That is the technique is electrical imaging is uh, depending on your area, but of course the instrumentation is very important to find out your groundwater and for in underground investigations. Um, the our system has a very good, let's say, high resolution receiver in the instrument. That's like a you can really get like a signal as low as like 0.02 millivolts. So like a resolution is 30 nanovolts, but however, as in practically, you will get about 0.02 millivolts, which is very weak signal, but in our system can get that signal is clearly. So in that's the one thing is to get a very good data point in the resistivity imaging. Once you have a very sensible the receiver, that will increment your weak signal is getting cleanly less noisy and then better way. So starting from there, instrumentation. So once you have like a good instrument for a very high resolution receiver, and of course is the um, electronically free noise transmitter, then the combination of transmitter and receiver will give you good the reading in the field. That's the first thing to have it start under resistivity imaging. When you have a good things, and then you're able to get a good data. But it's not all. So also is depending on the field conditions and the geological conditions and what type of the geology or hydrogeology is related with your groundwater. That's other issues in related. So then let's say if you're looking for groundwater in the fractures or if in groundwater is related in the very thin, like a faulting zones. Then everything related with your survey resolution sense, which is how electrode spacing is spread on that related that area. So that like if you're looking for a 5 meter fracture where the groundwater is if infiltration go through, in that case then you need to set up your electrode spacing maximum 10 meters. So what I'm talking about is for 2D studies generally. But when you do the 1D, and also you can try to make Schlumberger sounding depending on where you are. So like efficiency of the groundwater or any other underground investigations. So we need to set up first on the electrode spacing based on our expectation for resolution sense. The other thing is what I described at first is the instrumentation very important because of that high resolution receiver is our key issue, which is in the super sting is very well known. In that case, you may already some of them has experience very well. Is like a weak signal can really be detectable and collected and recorded easily without noise. So that's the like a key point for any investigation, not only for groundwater. Okay, another question. Let's say Kasim Zahta. Good morning, Kasim. Just go ahead, please. Well, accuracy is just the I mentioned it is a receiver is a high resolution, right? That like what that means is a receiver maximum resolution 30 nanovolts, but that's for the laboratory conditions. And but in the practical point of the in the field studies is about you can get very weak signal like what we call it 0.01 0.02 millivolts, especially in the superstring is widely used in marine studies for salty water environment, which is where you usually get very weak signal from there. But very clean signal in our case is you can get it like a 0.01 0.02 millivolts. So that in order to get that unity design instrument is in the for power output and receiver sense is in the accordingly it doesn't give much noise. So that like what we has optimum receiver output in that case adjustable automatically depending on your contact resistance depending on your conditions, and the receiver will get very high the signal from the ground. Okay, the depth is depending on the spread. Like in supersting has been used over more than 500, like 1,000 meters depth of investigations. So I got clients in for geothermal studies. They are doing for deep electrical sounding. As you know, superstring has like a 100 and 200 watt power outputs depending on the normal mode and boost mode. Only for like a normal mode, I got clients has done with just using one single battery. For deep vertical electrical sounding, like AB spacing is almost 7 kilometers separated, and then they will get about more than 500, almost 1,000 meters depth of investigations. So if you really need a more depth or depending on the area, of course, is the if you got a very high contact resistance areas, you will not get that depth. So in that case, you can also use our high power output transmitter. What we have is an external transmitter. The power sting is also available to using together supersting to get achieve for like high contact resistance areas or deep ocean bottom studies also need some more power outputs. In that areas, you can use external transmitter, but only for using superstring, you can really get up to about, I would say, 1,000 meters depth of investigation. But most of the studies is generally is not that depth. No problem. Okay, I see Safa is just raising your hand. Yeah, of course. I mean, my question is are you located in a very, let's say, I don't know where you're located, but um, you can, like uh, you can really get all the lithology separation, like limestone, sand, gravel, any aggregate mining, you can do it. So it as long as if you have a the resistivity contrast in the area, which is yeah like you're looking for maybe limestone for construction purposes. Definitely, you have a limestone is very resistive in most of the cases. If it is not like a karstified limestone, the the resistivity contrast is the key issue in all resistivity imaging. Uh, like first, what you have general for soil and clays in the top, it is very on the upper part is maybe resistive, but in general for the clay, the moisturized is an you got always conductive. On the bottom of that is you have a like a limestones, let's say you have a different resistivity values. Maybe it's changing from 100 ohms to 10,000 ohms. So when you get like a very high resistive values, you will really know that your limestone is very compact and massive. It's almost let's say they are the marble. But if you get a limestone is about very weak, let's say 100, 200 ohm meters, of course, depending on the surrounding resistivity information, because what you measure generally is not only one thing. You measure the volumetric average values. but that will give you for reasonable information about for if you're on the same lithology. The lithology, it doesn't matter granite and limestone or the basalt, anything, but is resistivity is very high, and then you got a really compact, massive material there. If it is less, it's the same material will give the less resistivity, which is like a maybe moisturized, maybe for calcified, that will give you for the quality of the material. So for quality of the material, you can really also see with resistivity ranges. Is that answer your question? No problem. Well, okay, thanks for the question. So that question is uh, depending on the, are you doing vertical electrical sounding? Let's say if you're doing vertical electrical sounding, typically vertical electrical sounding is the Schlumberger electric sounding. And in that case, in three people will be sufficient. So like a one operator in the middle and then two person in the for the current A and B current locations. So this is typically manual measurement for vertical electrical sounding for Schlumberger sounding, what we call it. So in that case, three people will be sufficient. But in general, what people is doing is part of 1D is the 2D studies, and 2D studies is depending on the number of electrodes also. But typically for mostly used systems, it's about 56 electrode. But it doesn't really matter 56 to 28 or 112 or 84 electrode system, multi-electrode systems. Depending also for how long your cable spread is. So if it is a like a 2 kilometer cable spread, if you have it, so it's there's a loss of cable, and you may need more people. But it's typically about including 3D studies, say 2D studies, 3D studies, same thing. I think uh, at least minimum three people you really need it to do this kind of the works. But if you have a long spread, of course, if you have more people, that will be takes less time of the the putting everything in the ground, because it's the imagine you need to put like a 1,000 or 2,000 meters of cable laying down and putting the electrodes like a 84 electrodes. If you just have three people, maybe it will take 2 hours to do that. But if you have like a six or four or five people, and it will take less time of the laying down everything and also picking up after the measuring. So um, typically is 56 or 84 electrodes, about four people or six people, depending on your the crew. It laying down everything, preparing the field is at least in an hour, I should say. So you just put like a 1 hour of the the field preparations, and then or maybe 1.5 hour, and then you start measuring at least depending on the array type. Maybe you do general what we recommend dipole. With 56 electrode dipole, it will take about maybe in 40 minutes of measurement. Or if you want to add it like a gradient, dipole gradient, maybe we're talking about 1 hour of measurement. So like it also depending on the array type, you may spend of measuring 1 hour to 2 hours in the field. So then also picking up everything is about half an hour to the 1 hour, I would say. So like it typically is in 4 hours in a half day, you can do like a one spread. Let's say one spread at least in 1,000 meters or 2,000 meters cable length. Okay. Yes, you can do that. Is typically if long spread is I got client for example is 84 electrode. They have a cable of 1,600 meters, and in four hours, and they just do one spread and one measurement, and then afternoon they do another like a two lines they do in per day almost. If you wanna, faster, you need more people. If you have just doing the one line in per day, I mean, three people will be also is sufficient to do that. The other questions of yours in the it has to be like you cannot find always the flat areas. There's a mountain areas also that makes the task is difficult sometimes in the mountain areas, and then there are lots of trees and bushes and water and river you need to pass. So that will be also the other influence of the this kind of this laying out the system. But once you have mountain areas and then topography also you need to take in account. So you need to take a topography measurement, which will be used later on for the data processing. Yeah, I mean, it's because in field work has to be done in any time of the year, so it doesn't matter hot, cold, and the rainy. But if it is the one thing is in summertime, if you're in the dry areas, in that case you need to put on the contact resistance increase in the summer areas and in each electrodes. In that case, you need to put more water or salty water or bentonite solution for each electrode. Keep the moisturized electrodes during the hot weather conditions. Gives the good readings. That's very important for electrical imaging to keep an eye always in the low contact resistance in each electrodes. But in winter time, as if it is rainy, I mean during the rainy time, nothing happens to cables or instruments. But only thing is what happens is generally um, the water start filtrating into ground, and then that creates a noise and like that creates what we call it streaming voltage. So that will for us for measurement is like a noisy data. You start getting it. So if you have a heavy rain areas, just stop the measuring, wait, like after even if after rain stop, wait that water infiltration is the finish in maybe in half an hour, 1 hour, then start measuring. Okay, yeah, the instrument can reach that depth, but the problem is in the resistivity imaging resolution. Um, like for super sting, in order to get that depth, you need to use a power sting. With power sting and super sting, you can really get that depth investigation. However, the resolution you will not get that what you're interested in because in order to get like a 3,000 meters or 2,000 meters depth, you need to spread your cable is almost 5 times more. So like we're talking about like a 10 kilometers or 15 20 kilometers of the cable spread you need to do. So that will give you like the depth of investigation. But maybe you're looking for like an oil reservoir is about a couple hundred meters thick in about sitting in the 2,000 meters depth. That you will not get that resolution in that depth. So that's the key issues. Is also difficulties is like putting 20 kilometers of the spread cable length is not easy. So in such that the depth, it's better to use other technique like maybe is best things always using seismic. That's the one of the issues getting that depth and high resolutions. But I do have clients also using for oil and gas for resistivity imaging, but not that depth for shallow investigation, especially for deep ocean bottom studies. I got some oil companies, they are trying to use our system to get like almost 2,000 meters under the oceans, about 300 or 500 meters depth of investigation for oil and gas investigation under the ocean. In that case, yes, that's reasonable to use it. But on the land, I wouldn't say, like to use that system for that type of investigation for resistivity. Maybe it's better, other technique is better way to use it. Yes, for the depth of the range, you can get reasonable depth of investigations generally, and then with resolutions. But depending on the if again is resolution sense is always like any geophysical method is same, but in resistivity imaging, when you're close to electrode, you have a high resolution for it's true for any other geophysics method. But when you go like a deep and you need to look at for the larger side of the size of the anomalies, like a 400 meters depth maybe, and you need to go through maybe is about at least in 50 meters and 80 meters the thickness of and more on the size of the anomalies. You will not get like a couple of meters the thick is in the anomalies in that case. No problem. Okay, I think Nabil is tried to. I see his question is Okay, he says, my question is about interpretation of the result, which is the most important for the client. It is about quality of rock beds. Here is in Palestine, all clients are interested to know quality and quantity of the bedrocks before acquiring uh, and the bedrocks before acquiring, and this needs to good be interpretation of the data. Okay, that question is similar like she asked before, like a few Safa asked a few minutes ago. So again, this the quality of the rock is really is a not. I should say like this: you cannot go on in the field just take a one measurement and decide, okay, this is a like a soft rock or karstified rock or like a massive rock. So we need to know for sure in some other information to correlate our results. So resistivity will give you for like a high resistive, like a massive material, like the same lithology we're looking for, right? Measuring in the same area. So like a, let's say you have a marbles or karstified limestone or massive limestone. It will give you different resistivity values, but when we get for interpretation, we don't really know which is the, in that case, is the value is corresponding massive or uh, let's say karstified or weak zone. So we need to tie that information with some drilling information or with some previous information. If you have that information previously or after this resistive imaging, we drill it and then we test it and we combine that information, correlate with that information, then we can able to interpret that easily and to understand exactly what value is corresponding that quality of the rod. But once you start doing this a few times, if because in most of the studies, more you're doing in the general same areas, the same areas changing a little bit in one to other things. But then you start, the using the same information for other zone in the same area to correlate that information. Then you can decide easily, okay, I have this massive rock in the area because of resistivity value over 5,000 or 500, depending on the area, and then you can really say for the query of the quality of the each rocks and bedrocks. Okay, he's adding that this means it is necessary always to have drilling parallel to geophysical investigation. Well, not always, but it is good things to correlate. If you can correlate that information with other background geological information or other uh, information with previous drilling, uh, that will help. So because it's not always possible to after any geophysical resistivity imaging survey you cannot go and drill depending on the money, depending on the target, depending on if it is a client is paying to do that. But what you can do is always you check up for any previous drilling in the area, any information, core information, geological information, then try to um, correlate with that information with your results. That will help. Okay, Dr. Ayalavi is asking, how do I generate protocol for vertical ethical sounding? Okay, that he's offline, looks like. Um, okay, that one thing is in if you're doing a manual measurement with our system, there is no need to create any protocol in the instrument. So instrument has a manual mode. You can just choose for any type of the vertical sounding, like a Werner or Schlumberger, you can do that. However, if you want to do it like what we call it with using your multi-retro system, then I can help you to prepare protocol for that. So in that case, you need a protocol, what we call it command line. I can prepare a vertical ticket sounding manual command line for automated mode, then you can use it. Just let me know when you need it, anything. Okay, go ahead, Safa. Okay, like if you want to do it 2D studies, okay, like a 40 meters depth, you need to go about let's say 5 times of the like a 200 meters and spread, okay, and then in 200 meters spread will give you 2D results, and then you need to do parallel lines for to cover for 3D. Uh, Generally, for the parallel line spacing will be depending on the electrode spacing. Let's say you have a 5 meter electrode spacing, then I would suggest to do like a 10 meter line spacing, and 10-meter line spacing will help to real 3D inversion later on because you can combine 2D lines for 3D images in inversion. That's one thing you can do. Other thing is you can split the 3D layout. That's depending on the electrodes, number of electrodes. You can really make like a square grid or rectangular grid or any shape of the area. You can do that. You just create a 2D, 3D grid, and then you can get like a the depth of investigation required. Let's say you want a 40 meters. So like you have a large area, then you can put like a 5 times expanding almost in the area. You can do that with any these are general for what I'm talking about, regular electrical arrays like a dipole Schlumberger graded arrays. Of course, when you use pole dipole array, then you will get like a shorter electrode spacing, I mean shorter spread, cable length, shorter cable length, and then deeper investigation. But typically, like I can give you one other thing is if you want to do like a 40-meter depth, you can do like a 3D layout, like a 40 by 40, and then use a 3D pole, and you will get really 40 meters depth of investigations. Okay, no problem. Okay, Nima, I cannot hear yet, but here's Josephine is asking is I have very low resistive structure at about 250 meters depth. Will my 112 electrode system be able to map this? Okay, so like a low resistive structure or high resistive structure will be depending on the in the in the extreme cases what we call it. Like I will say low resistivity is if you're on the seaside, for example, salty water environment, and then you wanna get it like a you wanna get it 250 meters. So like what we call it, you just go like a 1,250 meter is the cable length. So if you use about a 10-meter electrode spacing with your 112 electrode system, you will get that depth of investigations. But um, generally, you can calculate your depth. Let's say your spread is a 1,000 meters, okay? And if you're on the salty water environment, which is very conductive zone areas, and then I will say 15% of your cable length. Let's say I have a cable length is 1,000 meters, then I can reach about 150 meters depth of investigations. But if I am in the good conditions, not very low, let's say not very salty water environment, is in typically in the most of the ground, you really get about 20%. Sometimes you can get 25%. So I should say that 1 meter the spread, like a cable length, you can get between 150 meters to 250 meters for any dipole-dipole array or gradient array generally. But if you like to do pole dipole array, and then you can get about the 300 to 400 meters depth of investigations. Okay, I think Safa, I missed that part also, that her question. So if you want to have accurate information for 300 meters square to 40 meter depth, how many electrode rods or channel I have to use? Okay, that's depending on what you have it. So let's say if you have more electrodes, then you can put your electrode spacing is shorter, get higher resolution, and in that case, it will be is better for high resolution, and then but it will take longer of measurement because more number of the electrodes. But 40 meters depth, typically you can use 28 electrodes or 48 electrodes, 56 electrodes, 64 electrodes, any number, depending on your what you have in the area. But since you're going to cover 300 meters square, uh, maybe is an not very big area, but maybe you can, if you have a more electrode number, you can make a 3D spread in the area. You can cover for your depth easily. Yes, Shazad, go ahead. Yes, especially in summertime and or most of the time. Yes. Okay. The, yeah, that's good thing is in the sand areas, dry areas, it's difficult to get the good contact resistance. Like in any electrical imaging, and um, it is the key issue is always keep the contact resistance low. So in our system, I will say is in if you're doing resistivity imaging, contact resistance should be less than 5,000 ohms. That will be to get a good data. But if you're doing resistivity and IP, and then in that case, contact resistance should be less than 2000 ohms. So sometimes when you go like a sand dunes area, especially sand dunes areas, more complicated, difficult areas, um, depending on the sand thickness, uh, it doesn't matter what you do. You don't get really the low contact resistance. So in sand dune area, maybe it's a half a meter or 1 meter sand thickness, dry sand thickness. In that case, you need to use a long rod, maybe in a 1 meter, 2 meter, 3 meter rods. But there is no other way to reach underground. But in the normal sand areas, in general, in Saudi Arabia, in all these regions, I know that when you dig little bit, sometimes it is a moisturized, salty under it. But even if it's not like a salty in the moisturized in the areas, so all you got a thick uh, maybe half a meter on thick sand, dry sand, I will suggest to dig it a little bit and then put bentonite the solutions in the when you put the rod in the stainless steel electrode in the ground, put the rod and then just that moisturize for bentonite, it will make that contact resistance is lower, and not only lower in contact resistance but also keep longer time of the moisturize, like almost a half a day of the moisturize, and then that will guarantee for the during whole your measurement whole day low contact resistance. But again, in sand dune areas, um, the other option is to use for a external transmitter power sting, because power sting is designed for high power output. Super sting has a like a 200 watt and 400 volt and maximum 2000 milliamp current output. But in sand dune areas, let's say you got a 5 meters and 10 meters sand dunes, there is no way to use for this super sting in such areas. In that case, yes, in that case, you need to use power sting. Like we have a three different model of power sting, like a 5,000 watt, 10,000 watt, and 15,000 watt. So these are like almost you can put like a 1,000 volt, 2,000 volt, up to 3,000 volt, um, and 5 ampere to 27 ampere, up to 27 ampere current output. In in high dune areas, what you need is in the high voltage output, low current output power sting, what we call it. So let's say like a power sting 10 kilowatt is 2000 volt voltage output and maybe about less than 5 ampere current output. That will work in such areas. Okay, the Wi-Fi signal is about 100 meters range. So yes, so it will give you a great, like the challenge for the clients then when you're in the field, you're not on the stick on the front of the instrument, so you can walk through your line. Maybe you have you can go like a right or left side of the because an instrument is always staying in the middle of the cables, right? And then you can go about 100 meters right or left in the area. You can check your electrodes through from the tablet. You can also see your results sometimes in the Saudi Arabia. It's very hot, and then you can just leave your system outside. You're in the inside of the car. You can control through your measurement from tablet. The tablet will give you very good things to achieve good data quality in the field, because you're observing not only the numbers for like a, you can really see all each measurement, voltage values, current output values, input values, error values, and not only the values but also for 2D physical sections in the field, because 2D physical section is to see is very important before the finishing up the work. Once you're done, I mean, you see all things while measuring simultaneously. But at the end of the survey, also you can see everything completely. So, and that will give you for the good data quality. So before picking up everything, let's say you start with the dipole, and then you see your section, and then your section doesn't show any odd numbers. Like when you have odd numbers, what I say is the negative values, very high numbers, and then digital section will have a highlighting white dots and black dots. So that means you don't have like much white and black dots. That means your measurement is good. So that means that your data quality is good in the field for dipole what you did. So in that case, yes, you can just like finish up. If you see that is not good, then you may do another implement like doing strong gradient measurement and just 10 or 20 minutes more, and then get another the data, combine it later on, make a the joint inversion for both of them. Yeah, from supersting is about 100 meters away, but you shouldn't put like as like a um, destroying signal between. Sometimes if you have the phones or other influence and signal, electromagnetic signal influence in the middle, and that's also interrupter for communication. But once you have a tablet interrupted in somehow, because you're on the other side of the car and the car is block all signal, or another telephone, if you lose it, but you don't lose nothing. Instrument always keep measuring, and then you can go back the instrument and then just synchronize again with the tablet, continue is whatever is the instrument is continuing from there, you can see it. Hello, Josephine. Okay, like as you know, the instrument has a when you open it, it is a one is automated mode, and then two is manual mode. In the manual mode, you can do like a vertical electric sounding and VES, and just picking up that, and you don't have to create anything, any protocol, anything, nothing. Just follow up from that from the manual mode. You can use manual cables for real cables, and for electrode, you can do your vertical electric sounding easily. So, like let's say you want to do Schlumberger, okay, just go to menu 2, manual mode, pick, create a data name, and then choose this Schlumberger sounding, and then each time what you need to do, enter for AB over 2 spacing, MN over 2 spacing, and then keep measuring. That's the easy way. So other thing is about for what was the other question? Can you repeat? Yeah, that's what I'm saying. That protocol VS for manual mode, you don't need to create any protocol. You can just use for manual mode directly. Yeah, okay. If you want to do automated mode, okay, then we need to create a protocol. Like in automatic mode, that means is you need your multi-electrode cables for using vertical electric sounding. But in that case, is sometimes it's too much to put all your cables just what do one single vertical electric sounding measurement. It is easy, faster way to do for real cable and using manual mode to do for vertical electric sounding. Okay, no problem. Okay, we're almost closing end of the session. Let me know if anybody wants to have any question. Uh, I see two hands still is rise up, and Nima, and I don't know if he wants any question, but in any case, what I will do, I will follow up all these questions again with email. I will follow up in each of you about this session, and then you can ask me also through the email, or I can contact through each of you when we need it, really need it in another meeting. We will follow up this kind of the question and answer meeting is very often. Um, if if there is no question, then I will try to finish up this today. Well, thank you all for joining this session. I hope you enjoy also all this, and please just you can send me freely anytime in an email or just WhatsApp chat, and also you can go to our webpage. We have a help desk, and we have many information in the help desk, and we have many resources in the webpage. You can chat online directly with us through the through the help page and the chat online. We will be available anytime. Thanks for again. Have a good day, everybody.